A real number is either a rational or an irrational number. A rational number can be written as a fraction or a decimal, and that decimal is either a terminating or a repeating decimal. So examples of rational numbers would be 1/2, 8, which we could write as 8 over 1, -2 5/10, square root of 49 over 81, which would simplify to 7/9. Or you could have 4.2, 1.6 repeating. These are all examples of rational numbers because they are either fractions or terminating or repeating decimals. So a real number is either rational or irrational, meaning not rational. If it is an irrational number, it cannot be written as a fraction. Irrational numbers are both non-repeating and non-terminating. So they never repeat and they never terminate. They never end. If you take the square root of a number that is not a perfect square, it will always be an irrational number. So the square root of 2 or the square root of 24, 2 and 24 are not perfect squares. So taking the square root of those numbers would give you an irrational number. Any number with pi in it is also irrational. So pi or pi plus 2, those would be irrational numbers. So a real number is either rational or irrational. If the number is rational, as you can see in the diagram here, we have subsets of a rational number. If it's rational, it could also be an integer. Integers are all the whole numbers and their opposites. So all the whole numbers, 0, 1, 2, 3, and on, and their opposites. So -1, -2, -3, and so on. That makes up the set of integers. All integers are rational. As you can see, the integers circle is inside the rational circle. So the integer set is inside the rational set because all integers can be written as a fraction or a decimal. But not all rational numbers are integers. You can be a rational number and not be an integer. An example of that would be like 1/2, right? 1/2 is a fraction. It is a rational number, but it is not an integer. If you are a rational number and an integer, you could also be a whole number. All the whole numbers consist of the counting numbers, so numbers that you would start with to count, 1, 2, 3, and so on, all the counting numbers and 0. That makes up the whole numbers set. And so what is unique about whole numbers is that they are all positive. All the whole numbers are positive. There are no negative whole numbers. As you can see here, the whole numbers circle, the whole numbers set is inside the integers set and inside the rationals set. So all whole numbers are also integers and also rational numbers. We'll do a few examples. The first one, we'll take 0.3 repeating, and we want to put it inside the correct set. 0.3 repeating. Well, we know that if it's a repeating decimal, all repeating decimals are rational. And so if it's rational, I must also think to myself, okay, could it be an integer? Well, 0.3 is a decimal, and there are no decimals that are integers. So 0.3 repeating is a real number, and it's rational, real and rational. The next example, let's take the cube root of 27. The cube root of 27. Now, what you should know about 27 is that it is a perfect cube. So if you take the cube root of 27, you would get 3, right? Because 3 multiplied by itself 3 times would give you 27. So if we simplify the cube root of 27, we get 3, and 3 would be a whole number, right? It's rational. We could write 3 as a fraction by putting it over 1. It is an integer, and it's also whole. The next, let's take the negative square root of 64. Well, the square root of 64, since 64 is a perfect square, what number multiplied by itself will give you 64? You should say 8, right? So the square root of 64 would be 8, and we want the opposite of that. So the opposite of 8 would be -8, and -8 would go in the integers set, right? It's rational, It could be written as a fraction by putting it over 1. It's also an integer. But it's not a whole number because remember, there are no negative whole numbers. Last example we'll do is the square root of 27. The square root of 27. So think to yourself, is 27 a perfect square? Well, no, it's not, right? 25 is a perfect square, 36 is a perfect square, but 27 is not a perfect square. And remember, if you take the square root of a number that is not a perfect square, it will always be an irrational number. So the square root of 27 we would put in the irrational set.